This video is on the circulatory and respiratory systems, section 1. Most cells are not in direct contact with their external environment, so the circulatory system acts as a transport service. There are two fluids that move through the circulatory system. You have blood, which is transported through the cardiovascular system. The cardiovascular system consists of the blood, heart, and blood vessels. And then you have a second liquid called lymph, which is transported through the lymphatic system, which includes the lymph nodes, and lymph vessels. If you are asking yourself, what is lymph? It is a fluid that tends to build up inside body tissues, which then has to be transported back into the blood. If you've ever had a blister that when it pops, there's fluid that comes out, that fluid is lymph.
Your heart is a pump. It's a muscular organ about the size of your fist and is located slightly left of center in your chest. Your heart is divided into the right and left side. The division protects oxygen-rich blood from mixing with oxygen-poor blood. Together, your heart and blood vessels comprise your cardiovascular system, which circulates blood and oxygen around your body. In fact, your heart pumps about 5 quarts of blood every minute, and it beats about 100,000 times in one day. That's about 35 million times in a year. Oxygen-poor blood, blue blood, returns to the heart after circulating through your body. The right side of the heart, composed of the right atrium and ventricle, collects and pumps the blood to the lungs through the pulmonary arteries. The lungs refresh the blood with a new supply of oxygen, making it turn red. Oxygen-rich blood, red blood, then enters the left side of the heart, composed of the left atrium and ventricle, and is pumped through the aorta to the body to supply tissues with oxygen. 4 valves within your heart keep your blood moving the right way. The tricuspid, mitral, pulmonary, and aortic valves work like gates on a fence. They open only one way and only when pushed on. Each valve opens and closes once per heartbeat, or about once every second. A beating heart contracts and relaxes. Contraction is called systole, and relaxing is called diastole. During systole, your ventricles contract, forcing blood into those going to your lungs and body, much like ketchup being forced out of a squeeze bottle. The right ventricle contracts a little bit before the left ventricle does. Your ventricles then relax during diastole and are filled with blood coming from the upper chambers, the left and right atria. Then the cycle starts over again. Your heart is nourished by blood too. Blood vessels called coronary arteries extend over the surface of your heart and branch into smaller capillaries. Here you can see just the network of blood vessels that feed your heart with oxygen-rich blood. Your heart also has electrical wiring, which keeps it beating. Electrical impulses begin high in the right atrium and travel through specialized pathways to the ventricles, delivering the signal to pump. The conduction system keeps your heart beating in a coordinated and normal rhythm, which in turn keeps blood circulating. The continuous exchange of oxygen-rich blood with oxygen-poor blood is what keeps you alive.
Okay, so that was a whole lot of information in about 4 minutes, and I will probably break down this section into different videos because there's just a lot in this section. And I don't want you to have to sit down and watch like a half-an-hour video. So the main focus of this video is going to be on the heart. The heart is the central organ of the cardiovascular system, and it beats more than 2.5 billion times in an average lifespan. It is located in the thoracic cavity behind the sternum, which is the breastplate here, basically where your ribs connect, and it's between your lungs. Very similar to bones being covered with periosteum, the heart is covered with a tough sac-like membrane called the pericardium. Again, cardium means heart and peri means to cover. The pericardium also secretes a fluid to help reduce the friction as the heart beats. Now, separating the right and left side of the heart is something called the septum, which is here. And again, here's a heart cut in half, and the septum is here. Now, what's going to be confusing is that when you're looking at a heart, the left side is actually the right side of the heart and the right side is the left side of the heart. You have to think about it as in, like, from your own perspective, the left side is here and the right side is here. So it's the opposite when you're looking at it. So the right side of the heart is normally colored blue because it contains deoxygenated blood, and it's going to receive blood from the body. It's going to receive blood from the body. There's two big, I can't use red on red. Two big vessels, one bringing blood from the top half of the body and one bringing blood from the lower half of the body back to the right side of the heart. And then it goes from the right atrium to the right ventricle. When it leaves, it goes out to the lungs to get oxygen. The left side of the heart is going to receive the blood that just came back from the lungs, which is freshly oxygenated. That's why the left side of the heart is colored in red. And that's going to receive blood from the lungs and then pump it to the rest of the body. Now we have two upper chambers and two lower chambers of the heart. So on the right-hand side, which is on your left, you have the atrium, the right atrium, which is the upper chamber on the right side of the heart, and of course the left atrium on the left side, and the two lower chambers are called ventricles. The atria are going to receive blood from the body or the lungs, and then the atria will contract and pump the blood into the ventricles. The ventricles will then contract and pump the blood through vessels, either going back to the lungs or to the body.
The circulatory system, consisting of the heart, arteries, capillaries, and veins, is the pumping mechanism that transports blood throughout the body. In the heart, the left ventricle contracts, pushing red blood cells into the aorta, the body's largest artery. From here, blood moves through a series of increasingly smaller arteries until it reaches a capillary, the junction between arteries and veins. Here, oxygen molecules detach from the red blood cells and slip across the capillary wall into body tissue. Now deoxygenated, blood begins its return to the heart. It passes through increasingly larger veins to eventually reach the right atrium. It enters the right ventricle, which pumps it through the pulmonary arteries into the lungs to pick up more oxygen. Oxygenated, blood re-enters the left atrium, moves into the left ventricle, and the blood's journey begins again.
Okay. So we have two sets of valves, two sets of two valves. There's 4 valves in total. You have a pair of atrioventricular valves, AV valves. This is separating the atria from the ventricles. That's why it's called atrioventricular. And they have their own names depending on which side of the heart it's on. So on the right side of the heart, it's called the tricuspid valve. And on the left side of the heart, it's called the mitral valve. Again, valves are there to prevent backflow of blood. It's there to ensure that blood is always going in one direction, because your circulatory system is set up so that blood is always flowing only in one direction. So these prevent backflow. Okay, so between the atria and the ventricle are atrioventricular or AV valves, and on the right side, tricuspid, left side, mitral. Now, separating the ventricles from the blood vessels that leave the heart, these are called semilunar or SL valves. On the right-hand side, you have the pulmonary valve. And a way to remember, it's here, a way to remember that is pulmonary means lungs, related to lungs. And so that's on the right side of the heart, because the right side of the heart is the circulation between the deoxygenated blood going to the lungs. So pulmonary valve is the valve leaving the heart going to the lungs. That's why it's called pulmonary. And then on the left-hand side, you have what's called the aortic valve, because it's going from the left ventricle into the aorta, which is the largest blood vessel in your body that comes directly out of the left ventricle, going to take blood to the body.
This animation illustrates a single cardiac cycle, starting with the right side of the heart. In reality, of course, the two sides of the heart work together at the same time, but it is easier to understand if we look at them separately, because each side of the heart has a different function. The cardiac cycle begins as deoxygenated blood flows from the body into the right atrium via the superior vena cava and inferior vena cava.
I don't know if that's going to start again, but I just wanted to mention the superior vena cava is the blood vessel that brings the blood from the upper half of the body, and the inferior vena cava is what brings the blood from the lower half of the body. And I knew that was going to happen.
This animation illustrates
Okay.
In the next phase of the cycle, the right atrium contracts, pumping blood into the right ventricle through the tricuspid valve. Once the right ventricle fills with blood, the tricuspid valve closes to prevent blood flowing back into the atrium. The right ventricle contracts, forcing the pulmonary valve to open as blood is pumped into the pulmonary artery. Blood then travels to the lungs and the pulmonary valve closes. At the same time, the right atrium relaxes, ready to accept the next intake of blood. In the lungs, the blood picks up oxygen and releases carbon dioxide. Oxygenated blood flows from the lungs into the left atrium via the pulmonary veins. The left atrium contracts to pump blood into the left ventricle through the mitral valve. Once the left ventricle has filled with blood, the mitral valve closes. Next, the left ventricle contracts, forcing the aortic valve to open, allowing blood to be pumped into the aorta and from there around the body. The aortic valve closes to prevent blood flowing back into the left ventricle, and the left ventricle relaxes, ready to accept the next intake of blood. Cardiac cycle is now complete.
Okay. So I'm just going to go over that again slowly, again, remembering that both sides of the heart are going to work simultaneously, but you have to look at it one part at a time. So blood from the body is deoxygenated. It has a high concentration of carbon dioxide. It's going to enter the right atrium here from the superior vena cava and the inferior vena cava, and it's going to dump into the right atrium. The right atrium is going to contract, and that's going to push open the tricuspid valve and pump the blood into the right ventricle. The right ventricle is going to contract, which is automatically going to close the tricuspid valve, and the contraction of the right ventricle is going to push open the pulmonary valve, and the blood is going to be pumped into the pulmonary arteries, which branch off, going to each lung. In the lungs, carbon dioxide diffuses out, oxygen diffuses in. Oxygenated blood is going to return to the left atrium through the pulmonary veins. Those are the ones here you can see in the back. By the way, I should mention the pulmonary arteries are the only arteries in the body that carry deoxygenated blood, and the pulmonary veins are the only veins to carry oxygenated blood. So blood comes back from the lungs fully oxygenated through the pulmonary veins into the left atrium. The left atrium is going to contract, which pushes open the mitral valve, and the blood is pumped into the left ventricle. When the left ventricle contracts, the left atrium relaxes, which shuts the mitral valve, and the contraction of the left ventricle is going to push open the aortic valve as the blood gets pumped into the aorta, which then leads to the rest of the body.